I'm a developer advocate with EMC Code. That's a part of EMC that works on community open source projects. And for the past year, I've been working in the container space, mostly on Apache Mesos, but it is related to Docker and attaching volumes to Docker. Talk is called Heresy in the Church of 12 Factors. First of all, if you're at a meetup like this, I'm sure you're aware that containers are rapidly growing in popularity. This particular image was cut before DockerCon, so I think maybe some of the numbers in reality are even bigger than you see here, but bottom line is, by various measures, the adaptation of containers is growing at rates of hundreds of %. Even though they're growing, they're not all that new. You can trace these containers back to things like root jails that go back over 10 years. But to a lot of people, and I suspect many of you, containers feel like they're new. Because if you look at this job trends growth, a lot of the arrivals to containers have happened within the past year. Because there's a lot of new people coming here, they're undoubtedly going out to research the subject, learn about it, and where do you go these days? The internet. Well, the trouble is, even though containers, there's new people arriving to the container space, a lot of the content on the web isn't all that new. For the sake of humor, I cut and pasted a CNET review of cell phones from the year, the top 10 cell phones from 2011. And if you saw this whole list, they're almost comical, you know, even though it wasn't that many years ago. They'd laugh at you if you went out in public with any of the cell phones on this top 10 list. Well, the trouble is that a lot of articles on best practices for use of containers actually date back, like this one, to 2011. The 12-factor app is this dogmatic set of 12 commandments that advises you the best practices for deploying containerized apps, and the 12factor.net site has a little highlight at the bottom that says last updated January 2012. I think the 12-factor set of apps actually go back older than January 2012. One of the adages in the 12-factor list of commandments is that all containers shall be stateless. 100% stateless? How do you do something useful if every time you lose power to your data center, you get Alzheimer's and you lost everything? Is there something about this new containers and cattle that means that all my need for persistent storage just magically disappeared and I don't need it anymore? Well, the elephant in the room, of course, is that any useful app has state somewhere. You just kept it off in the corner and pretended that it didn't exist, but it was there. The state was outside the managed cluster that was running containers, and that's how you got things done. In fact, a recent tweet that I just love by Jonas Barney, there's no such thing as the stateless container. It just means it's somebody else's problem. Stateless is a hoax. Back in 2011, I will fully agree that it made sense with the technology available then that all containers should be stateless. If you look at how Docker containers work, for example, and if you were to try to save state inside the realm of the Docker container itself, the life of what's in that container is the maximum of either the life of the container or the node it's on. Oh, I'm in trouble here. So 12-factor says no database in containers, and you'll see the Docker image. Well, when you see this, no databases in containers, think of Cavill, think of the Docker ship, and say to yourself, bullshit. Now, it's not just me saying this. Docker Hub has a list of the most popular Docker images. 4 of these are clearly stateless. You've got Postgres, you've got MySQL, you've got others. You could argue that 7 of the 12 are in fact stateless if you deem that a lot of the people using Redis are using it in a stateful mode. So it's not just bullshit, it's flaming bullshit. Back in the old days, you put it outside, now you can run containers. What if you could take Docker, glue it to physical storage, Amazon Block Storage, Google Compute Engine storage, or OpenStack Cinder storage? Well, there's something that'll do it. It's called Rexray. I work on it. It's not a commercial. There's other things. They're called Docker volume drivers. There's a handful of them, Google for them, you'll find them. Now we're getting somewhere you can put databases in containers. So the advice is, if you can't change your mind, you're not using it. Things have changed. If you listen to that adage in 12-factor, you're missing opportunities. Thank you.
I don't have any slides. It's something that I worked on with a guy from Australia on the weekend, totally random, and I thought it's pretty cool. And I wrote a blog post about it, and people seem to like it. So it's very hard to run Docker environment, which is like you have multiple containers, services, databases, some web services. How do you write them? How do you orchestrate between them? And there's a bunch of frameworks that will help you to do it. One of them called Go Micro, or Micro, which I'm playing with. And there's also a project called NATS, N-A-T-S, which is a kind of a message bus. Maybe I'll show you the website of both of those projects. So that's NATS. They call themselves a central nervous system. So it's similar to Kafka or RabbitMQ or MSM, ZeroMQ, and those guys, but it's very, very simple. It's written in Go, so it's just an executable that you just run. It doesn't have all the features that Kafka has, like replay and stuff, but actually now they have a new project called NATS. Came yesterday or 2 days ago, NATS streaming. They're trying to add more features, so it will be more robust. But this version that I'm using is very, very simple. And basically, if you go to documentation, you can see that there's a bunch of concepts that you can use the pub sub, you can use request response, you can use queuing. In this demo, I think I'm using the pub sub version. So it's basically a queue that your services can communicate between each other. The other project that I'm using is called Micro, which is this product here. Allow you to write your microservices and manage them. It comes with a bunch of utilities, and you can also add more stuff. It's called Go Platform if you need authentication or discovery and all kind of metrics and logging. So I'll try to move my screen here to the right place. Give me a second. Where's my blog post? So in the blog post that I have here, you can see basically the flow. So this specific system receives events from the Bitcoin exchange network and also from the foreign exchange broker with WebSockets into those clients. And you can see that all the clients are connected to the message bus, and they send this topic. See the numbers going around this animation. They send a topic, and then somebody receives the topic. In this case, a tick recorder receives the topic from both of those guys, and then the tick recorder also publish a topic that will go to the Telegraph. Telegraph is a little component that lets you send stuff into the database, which is InfluxDB. So I'm going to use Docker Compose to combine all of those guys together. Hopefully I have enough time to show everything I want to show. Ooh, 2 minutes. Okay, so let's do DC up, Docker Compose up. And I have a bunch of, everything you see here is inside a container. Right, it's all working. Let's go to the browser now. And let's see. So this one is the registry. I don't really care about it right now. What I care about is to show you. This is our InfluxDB. Select star from. Trade. Or maybe not. Oh, I need to choose the database. Whew. Of course it didn't work. Start from trade, maybe? Maybe there's no trading information right now. That's another option. But yeah, basically, it's running a bunch of services. Let's see, number 81. 82 is my web console. So that's coming, microcom with web console, so you can see everything, all your services. In our case, it's only 3 that are just, publishing their existence to the system. This is the tick recorder, for example. You can see here it's connected to the NAT, and the broker can be replaced. Micro let to choose if you want to use Kafka, you can, but this specific one is using NAT. And it's using a protobufs, which is faster than JSON, very, very fast encoding. You have the CLI here if you want. You can do stuff like
20 seconds.
list of services from the CLI. What else? The repo is, go to my my website or my blog here, and you can look at the links here. Look at the repo, just investigate and look for yourself how to use it, and ask me if you have questions. Whew. Terrible. Thank you.
Hi, my name is Erik Osterman. I'm with Cloud Posse. We help companies be successful in the cloud by adopting or by helping them with their cloud architecture and implementation. We focus specifically on Docker and Kubernetes, among other things. All right, let's begin. As many of you have undoubtedly realized, we are seeing yet another massive transformation in how software is delivered. I'm going to call this a paradigm shift. It's that the containers are replacing virtual machines as the fundamental unit of deployment at an unprecedented rate. Apparently, Moore's law applies to the rate of adoption of new technologies as much as it does the density of transistors. In the enterprise, the rate of adoption of public cloud was twice that of virtual machines, and now we're seeing that same rate of adoption with containers versus the public cloud. You see, enterprises are interesting to look at because they are the slowest to move and therefore a consistent barometer of change. In this case, we're seeing that the enterprises are learning to be a little bit more risk tolerant. So what are some of the ingredients of a paradigm shift? Let's look at a few examples. So the concept of virtual machines, for example, have been around since the 60s, but the technology didn't catch up until the late 90s when VMware came out with the VMware Workstation. So what did they do with the VMware Workstation? They made it easy, first and foremost, for developers to run multiple workstations on their desktops. Then they conquered the enterprise with tools. Cloud computing is another one. Not a new concept, it's just that no one had really cracked the nut to show us how it was done. Then Amazon came along with EC2 and they made it accessible. They showed us the possibilities and let us write infrastructure as code, which blew our minds. So everyone followed Amazon and tried to do the same thing, except for they were a little bit too late. Because now we have containers. And they too have been around for a long time, as Steve was talking about. In Linux, the concept of containers have existed since at least 2008, when Google contributed them to the Linux kernel. But it wasn't until Docker came along in 2013 that they popularized it. And they did that by making it brain dead easy for developers to run them, and that's when we started to see the uptake. Now Docker is following suit with what VMware did by releasing tools for the enterprise with UCP, as Adrian was talking about, Universal Container Platform, and Docker DC, Docker Data Center. So what is the secret here? What is the common thread? And that's make it easy, target developers, and let it percolate through the enterprise until resistance is futile. So in the wake of all these transitions, there's been a lot of collateral damage, and these are the shims, the training wheels that we had to get us from bare metal to containers. And that's the natural process of innovation. Some examples of this are that there are over like a dozen hypervisors out there. VMware Zen and KVM, they're all going to see a massive loss of market share. Elaborate configuration management tools like Puppet or Chef were created to address the broken ways we configure software, basically emulated what we did by hand. But we don't write software as broken anymore, at least in that way, so that they won't be needed. And the other thing is all these EC2 knockoffs that orchestrate virtual machines, OpenStack, vCloud, and CloudStack, are now overkill. So why is it that the move to containers is happening so quickly? Well, I'm going to give you a hint, and it's not strictly technological. First of all, we can agree that anytime we iterate, the second iteration is easier, better, and usually faster than the first. And everything is less scary the second time around. So moving from a strictly bare metal strategy to a virtualized one was a monumental endeavor. However, this was the first, and that was because this was the first major paradigm shift of its kind. Now, that took convincing of both C-level executives and operations people, and it was a foreign concept, so the severe skepticism and pushback at every stage. Now, 15 years later, there's fresh blood at the top of the food chain. There's a new guard that's moved up the ranks, and that's being more accepting of this new technology. 1 minute. So with that, and the other thing is that enterprises are sick and tired of paying VMware millions of dollars for what they should be able to do for much less. So I'm going to wrap up now with a few predictions. It's going to be controversial. So VMware VMs are no longer going to be the de facto unit of cloud. Containers will replace them. If you still need a virtual machine, that's cool. You have a couple of options. You're going to run that VM inside of the container with Rancher. Well, not with Rancher, but a project I have called VM Containers. If that sounds absurd, ask how Google Cloud is doing it with with their public cloud on board. The Brave might try some kind of a unikernel, but it's still too early to tell. Interest behind OpenStack is going to start to wane. Innovation will cease because they were ahead of their time. We learned a lot from that experience, but now there's going to be a brain drain to Kubernetes and these other technologies. Amazon ECS is going to be end of life and replaced with offerings from Kubernetes and Swarm. And Kubernetes and Swarm will be battling it out for number one. Competition is a good thing. The best features of Mesos are going to be cherry-picked by both of them, but Mesos will fail to gain a bigger foothold. That's all I got, guys. Thanks. I'm Erik Osterman.
Yeah, I have a little bit of change of pace for you guys. My kind of use case I'm going to describe here is pretty primitive. There's no networking. There's no like visionary kind of amazing technology involved. But I want to share it because it's Docker's helping solve some pain points at my company over the last several months that may be useful or resonate with some of you guys. So I work at what you could call a medium-sized business, okay? So we're large enough to have a differentiated ops department that runs all of the deployment and provisions all of our computers, our virtual machines, what I call thick virtual machines, right? VMware. And so it's much faster to get new development environments and testing environments than it used to be because as one of my ops counterparts says, virtual machines are cheap. So what that means is when I file an ops request to get a new VM, it might get spun up in a day or two, but then there's another day or two to nail down the Puppet templates that define it. And that was working well for us for several years. But now that it's time to update the compiler and update some of the libs we use, now suddenly my little collection of about a dozen, 2 or 3 different versions of a compiler. And I can't just use, I can't just tell my Jenkins job to, for instance, temporarily install this different RPM while you compile, because that kind of ruins the whole concurrency of everything, because somebody else might want to run a series of tests to either build a new package and or test a package that needs different versions of these compilers or libs. So suddenly I was in the position of needing to double or triple or quadruple the number of virtual machines that I have in my test and development setup. And suddenly these virtual machines didn't seem so cheap anymore. So what I just started doing is simply having a Dockerized container that is nothing much more than GCC of a particular version with several of the libraries that we use. And using that then suddenly from my Mac or any of my individual virtual machines, I can point that at the source code and generate an RPM. And then a slightly different version of that Docker container has a different version of the compiler, the newer version of the libs. And so suddenly that has allowed me to use, it just multiplied the effectiveness and the resource utilization of my development testing clusters. Because now any machine can build any of the RPMs in any of the different versions. And now my only constraint is having runtime environments that can run them. But the developers are kind of realizing, hey, instead of using these shared libs at the system level, why don't we statically link this stuff? So that's a fourth Docker container I have now, one that can compile with the static libs. And so I'm just pretty excited that I was able to use Docker containerization to very quickly meet the demands of my dev and testing environment much faster than I thought possible. And I'm having fun learning Docker. Thank you.
You're gonna give us a little clap?
Okay. I have to start my own timer. All right. So I guarantee you've never heard a talk like this before, because nobody would come up in front of a bunch of tech guys who want to talk about personal hygiene products, because that would be weird. But I'm going to tell you a little story. In 1873, toothpaste existed, but back then it wasn't paste, it was actually powder. It came in a can or a bottle and you kind of shake it out. And it was actually made by a company called Colgate. And after decades of selling the product like this, in 1896, one of the founders of Colgate got the idea from looking at a paint tube that the toothpaste product could be delivered in a better way. It could be squeezed out of a tube, just like paint, right onto the toothbrush. And in 1908, Colgate actually made their slogan, "We couldn't improve the product, so we improved the tube." And they use this as their key marketing message. This is how they sold the product. Okay? Now, in 1962, they opened this place called the Colgate Research Center, which is where they did all R&D on all kinds of new variants of their product. Okay? And a few years later, in 1978, there was a lab assistant that worked in the research department. And this lab assistant had this idea and decided to go to the executive management of Colgate and say, look, I've got this idea that we can do that won't be very expensive and it won't be very hard. But if we do it, I guarantee you that our sales will double. And all I ask is for, if the sales double, that you give me 1% for 1 year. And they looked at him and they're like, you're going to double our sales? He's like, yep, I'm going to double your sales. And he offered him a contract. He pushed it across the table. And it basically said, as soon as I give you this, you're going to guarantee to give me 1% for 1 year. And so they're like, look, it's going to double our sales. It's only going to cost us 1%, maybe, if the idea even works. So why not? They signed the contract. And he says, would you like the idea now? Yeah. He said, make the opening twice as big. And that's exactly what they did. And sales doubled. And he got his 1% for 1 year. Yeah. Oh my God. That was really easy, wouldn't it? And that would be even more fun if that story were actually true. But a story doesn't have to be true to be compelling. There's a reason. Well, there is actually there is a thing called toothpaste tube theory. Basically, there's this concept of a bounded system. If you squeeze the bounded system, you get to a point of diminishing return where squeezing the tube more doesn't provide any additional. So this is actually something real. But my point in telling you this story is that innovation is not necessarily about a very complicated, great idea. It's sometimes about a very simple idea. And Docker wasn't about creating a new technology that was better and amazing. It was about making something that existed much easier. It was like making the hole twice as big. And I have 53 seconds remaining.
No way.
So I'm just going to stand here and stare at you for the next 53 seconds.
That was awesome.
Folks, thanks so much for joining today on behalf of AT&T. It's absolutely great to have you all here. And a quick shout out to our sponsor, Cisco. They've been very kind enough to also support us in this event. And of course, Adrian, Steve, Oren, Erik, Mark. Great stories. Loved your storytelling, absolutely. And so I wanted to talk about something interesting. How many of you have actually recently, or maybe a while ago, looked at a Docker Compose file, or maybe, let me see if I can do this. There you go. Let's see. There you go. Okay. So how many of you have actually done a Docker up on a Compose file? There you go. Quite many of them, right? it's truly a fun experience. When I discovered Docker a few years ago, the idea was quick. Before I go into that, I helped with cloud architecture area with AT&T, and we are going to talk about something interesting today. There you go. So when I discovered Docker a few years ago, it presented very interesting opportunities, things that you could do which otherwise would take a lot of jumping the hoops. A simple example would be AppArmor and SE Linux. So I'm a big believer in securing things and running something as a bulletproof item and then replicating it, scaling it up. And it always used to be a conundrum that, okay, you have a VM, do you actually install X amount of stuff? And Docker presented a very interesting opportunity. It actually allowed me to mount a Docker volume inside any given VM, have rootkits, SE Linux, AppArmors, Tiger. If you haven't used Tiger, it's really interesting tool. To actually run it from Docker, use the host VM's root file system, be just another volume inside accessing that container, and it would immediately tell you, or it would secure you up to great extent. Same thing with various range of tools. So typical Docker Compose file would look like this. It's still basically trades. It's still the unit of exchange is still all these infrastructure based thinking. So you have ports, you have volumes, you have network. So you would basically define something as a service. You would have a logical tie up to a web tier, front tier, DB layer. Yes, we moved from VM to Docker containers, but our thinking is still very much that. Where things are heading, Erik made a very cool mention about like prognostics. So where things are heading is when it comes to enterprise environment, just like VMs in a VM world, in OpenStack world or other way, a lot of it is intent driven, and the idea is that we want to be able to do intent driven computing. And if you extend that basically that line of thinking to containers, this is what this Docker Compose would look like in an operational intent driven world. And that's where really the enterprise would be able to leverage containers in a big way, that if you had adapters that would actually take your intent that, hey, I run this web tier in my environment prod, it would go and find out what prod means. It would then you would simply specify that because this is web, all what I want is these ports to be allowed from the web at this gigabit bandwidth. It would basically be smart enough to negotiate with your underlying infrastructure that this is what the intent was, and therefore I'm going to spin up these many containers in this location. So kind of like placement algorithm, a little bit of what Kubernetes does. So AT&T has got something very interesting going on called Music. It's on GitHub as well, so you should definitely check out. Extending this to DB layer, same intent could be translated as that you want to run this on network that has X amount of SLA. You want the failover policy. So this is very policy-centric consumption model. So you specify policy which says that trigger a switch to some geo site in Berlin. All what it does, it goes and puts 50 Kafka messages so that it triggers a chain of reaction. So that's the idea. Are we there yet? No. GitHub project called Concave is an interesting thing. You should probably check it out. But I think it'll be interesting for enterprise if they are able to do this intent-driven thing. Containers and Docker, of course, is going to fit seamlessly into a lot of knowledge base and a lot of best practices that enterprises have already built upon. So that's definitely a very exciting possibility to look forward to. All right, that should be it.
So again, thank you to Cisco for that delicious cider and beer and sodas and pizza and whatever other refreshments I missed. And thanks to AT&T Entertainment Division for hosting us and helping me with all the arrangements. For the next hour, we're allowed to hang out before we get kicked out the door. So you're welcome to mingle, and if there's any of that beer left, guzzle it down. Thanks, everyone.
Good.